In this video, we are going to simplify one of the most important and powerful Python libraries for statistical visualization, Seaborn. By the end of this lesson, you will understand how Seaborn works, why it's so popular among data analysts, and how to start using it to create stunning charts with minimal code. If you are a beginner in data analysis, don't worry, I'll explain everything step by step in a very simple way. So let's begin by importing the required libraries. First, we are importing the Seaborn library. Seaborn is a Python data visualization library built on top of Matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphics. We are giving it the short name SNS, which is the standard convention used by data analysts and developers. So instead of typing Seaborn every time, we can simply type SNS. This makes our code shorter and cleaner. Next, we are importing Matplotlib's PyPlot module. Matplotlib is the foundation plotting library in Python. Seaborn is actually built on top of Matplotlib, which means Seaborn uses Matplotlib behind the scenes to render visualization. We rename matplotlib.pyplot as PLT, which is also a standard convention. Even though Seaborn creates beautiful plots by default, we still import Matplotlib because we want to customize figure size, add titles and labels, adjust the layout, and display the plot using plt.show. So remember, Seaborn is a high-level, beautiful statistical plots, whereas Matplotlib is a low-level control and customization. Together, they make a powerful combination for data visualization. Next, we'll load a inbuilt dataset in Seaborn. So we are moving to something very exciting, which is loading a real data set. So let's break it down step by step. We are using the Seaborn's built-in function called load dataset. Seaborn comes with several preloaded datasets that are perfect for learning and practicing data visualization. One of the most popular dataset is tips dataset. By writing tips inside the function, we are telling Seaborn to load the specific dataset. The dataset is then stored inside a variable called tips. So now tips is a pandas data frame containing structured tabular data. So what's inside the tips dataset? The tips dataset contains information collected from a restaurant. Each row represents a single bill and it includes columns like total bill, tip, sex, which is the gender of the customer, smoker, whether the customer was a smoker, day, time, and size. This dataset is perfect for statistical visualization because it contains both numerical data like total bill and tip and categorical data like day, sex and smoker. That's exactly what Seaborn is designed to handle beautifully. Next, we print few rows of the dataset using the head. The head function is a pandas method that displays the first 5 rows by default. This is important because before creating any visualization, it is always a good habit to quickly inspect the data. This helps you to understand the data, see the column names, identify the data types, and get a quick sense of what we are working with. Think of it as a quick glance at your dataset before starting analysis. Next, we will create a visualization using Seaborn, which is a scatter plot. So let's understand this by line. We are using the Seaborn scatterplot function. A scatterplot is used to show the relationship between two numerical variables. It helps us understand whether one variable increases when the other increases, decreases, or if there is no relationship at all. Let's look at the parameters. The data is tips. This tells the Seaborn that the dataset we want to use is the tips data frame we loaded earlier. X equals to total bill sets the horizontal axis. We are plotting the total bill amount on the x-axis. Y equals to tip. This sets the vertical axis. We are plotting the tip amount on the y-axis. So what this plot is doing is simple. For every row in the dataset, Seaborn places a dot. The x value is the total bill. The y value is the tip. Each dot represents one customer bill. If the dots generally move upward as we move right, it indicates a positive relationship, meaning higher bills tend to have higher tips. This is one of the most common types of visualization used in data analysis when exploring relationship between two numerical variables. In the second line, we are using matplotlib to add a title to the plot. Even though Seaborn creates the plot, matplotlib is still controlling the figure underneath. This is why we imported matplotlib.pyplot as PLT. The title makes the visualization more readable and professional. Without a title, viewers may not immediately understand what the chart represents. Always label your visuals clearly. This is an important habit in data visualization. The next line tells Python to actually display the plot. In some environments like Jupyter Notebook, the plot may display automatically, but in scripts or certain IDE, plt.show is necessary to render the visualization. Think of it as a final command that says, OK, now display everything we created. So you can see that in 3 lines of code, we created a scatter plot, defined which columns to visualize, added a title, and displayed the final chart. And this is the beauty of Seaborn. Its clean, readable code produces powerful statistical visualization. Now we'll enhance our scatter plot by adding one very powerful parameter, hue. So let's break this down. We are creating a scatter plot between total bill on the x-axis and tip on the y-axis. But now we have added hue. The hue parameter is used to add a third variable to the visualization using color. Here sex is a categorical column in the dataset that contains values like male and female. What Seaborn automatically does is it separates the data based on the sex column. It assigns different colors to each category. It adds a legend to help us understand which color represents which group. Now, instead of seeing all points in a single color, we can visually compare tipping behavior between male and female customers. This is where Seaborn is extremely powerful. With just one additional parameter, we move from simple 2D relationship to a more important informative visualization that shows the relationship between total bill and tip, difference across gender categories, and pattern within subgroups. The plt.show displays the final plot. So if you run this code, you can see that we have points that plotted the visualization based on total bill and tip, different colors representing different genders, and a legend which is automatically added. Now we'll create a bar plot which is used to visualize comparisons across categories. So now let's understand what we did over here. We are creating a Seaborn's bar plot function. A bar plot in Seaborn is slightly different from a basic chart. By default, Seaborn does statistical aggregation for us. Let's look at the parameters. The data is tips as we are using the tips dataset. X equals to day. The x-axis represents the day of the week like Thursday, Friday, Saturday and Sunday. Y equals to total bill. The y-axis represents the total bill amount. Now here's the important part. Seaborn automatically calculates the average total bill for each day. It groups the data by day, computes the mean of total bill for each group, and displays those averages as bars. So each bar represents the average total bill for that particular day. So you don't write any group by code. You didn't calculate the mean manually. Seaborn handled it internally. That's why it's called a high-level statistical visualization library. Plt.title adds a clear title to the visualization. Titles are important because they immediately tell the viewer what the chart represents. In professional dashboards and report, the clear labeling is essential. The plt.show displays the final visualization. Without this line, in some environments, the plot might not appear. So in just 3 lines of code, we group data by day, calculated average total bill, displayed the results visually, added a professional title, rendered the plot. This shows how Seaborn combined statistical computation and visualization in one simple function. Now we are creating a histogram which is used to understand the distribution of a numerical variable. So let's break this down clearly. First, we are using the Seaborn's histplot function. A histogram shows how values are distributed across ranges. Instead of plotting individual points, it groups values into bins and shows how many observations fall into each range. Let's understand the parameters. We are using the tips dataset. The x equals to total bill. We are analyzing the distribution of the total bill amount. Seaborn automatically displays the total bill values into intervals or bins, counts how many bill falls into each interval, displays bar representing those counts, and this helps us answer questions like, are most bills small or large? Is the data skewed? Are there any unusually large variables? So what does KDE equals to true do? This is a powerful part. It adds a kernel density estimate curve on top of the histogram. A KDE curve is a smooth line that represents the overall shape of the data distribution. While the histogram shows group counts using bars, the KDE curve shows a smooth approximation of the distribution. This makes it easier to visually understand where most values are concentrated, whether their data is symmetric or skewed, whether there are multiple peaks. So remember, histogram is a bar which shows the frequency. KDE curve is a smooth line showing distribution shape. Together, they give a much clearer picture of how the data behaves. Using plt.title, we add a descriptive title to the plot. You should always label it clearly so viewers immediately know what variable is being analyzed. plt.show displays the final visualization. With this short piece of code, we are performing distribution analysis, which is one of the most important steps in exploratory data analysis. Understanding distribution helps to detect skewness, identify outliers, decide whether transformations are needed, prepare data for modeling, and Seaborn makes it incredibly simple to visualize all of that in just one line. Now we are creating a box plot, also known as a box and whisker plot. We are creating a box plot, also known as a box and whisker plot. This type of visualization is extremely useful when you want to understand the spread and distribution of data across categories. We are using the Seaborn's box plot function. Let's understand the parameters. We are using the tips dataset. The x equals to day in the x-axis represents the days of the week. The y equals to total bill in the y-axis represents the total bill amount. So what does this plot do? It compares the distribution of total bill amount for each day. Unlike a bar plot which shows the average, a box plot shows how much deeper statistical information is. The line inside the box represents the median, which is the middle value. The box itself represents the interquartile range, which contains the middle 50% of the data. The whiskers extend to show the range of the data, including extreme outliers. The dot outside the whisker represents outliers which are unusually high or low values. The plt.title adds a title to clearly describe what the visualization represents. Since this plot focuses on variability and spread, the title bill spread by day accurately reflects the purpose of the chart. plt.show displays the final plot. With this simple code, we are now visualizing not just averages, but entire statistical distribution of total bills across different days, which gives us much deeper understanding of the data. Now we'll learn how to improve the appearance of our visualization using Seaborn's styling options. So we are using the Seaborn set style function. The Seaborn comes with built-in themes that control the overall look of the plots, including background color, grid visibility, and axis formatting. By writing white grid, we are applying a clean white background with visible grid lines. This grid line makes it easier to compare the bar heights, read numerical values, visually track data across the chart. This small change significantly improves readability. Seaborn has a few common styles you should know, like dark grid, white, dark, white, and ticks. For most analytical visuals, white grid is a popular and professional choice. In the second line, we are creating the same bar plot as before. Since we already applied the style using set style function, this bar plot automatically follows that theme. It still calculates the average total bill per day and displays it as bars, but now with a cleaner and more readable design. The key thing to understand here is styling. Style setting affects all plots that come after them. You only need to set the style once and it applies globally. The plt.show displays the final plot. So you can see that with just one line of additional code, we have made our visualization look more polished and professional. This shows that good data visualization is not just about plotting data, it's about presentation and clarity. Now we'll create a multivariable visualization. The scatter plot function is again being used, which shows the relationship between two numerical variables. The x equals to total bill shows the total bill amount on the x-axis. The y equals to tip shows the total tip amount on the y-axis. Each point represents one transaction. But now we are adding two more dimensions to the same plot. The hue parameter adds color based on categorical value. Here day represents the day of the week such as Thursday, Friday, Saturday and Sunday. Seaborn will assign a different color to each day, automatically generate a legend and will allow us to visually compare tipping behavior across different days. Now instead of seeing all data points in one color, we can identify which day each bill belongs to. This allows us to observe patterns like do certain days have higher bills or are tips more generous on weekends? The style parameter changes the marker style based on another categorical variable. Here time refers to whether the bill was during lunch or dinner. So now color represents the day, marker shape represents lunch or dinner. For example, circles might represent lunch or triangle might represent dinner. The plt.show displays the plot with different colors for each day, different marker styles, and a legend explaining both hue and style. So with just a few lines of clean code, we created a professional multivariable statistical visualization. Now we'll load another famous dataset, the iris dataset. Just like the tips dataset, Seaborn provides several built-in datasets for learning and practice. Here we are using the iris dataset. This loads the iris flower dataset and stores it inside a variable called iris. So now iris is a pandas data frame. The iris dataset is one of the well-known datasets in data science and machine learning. It contains measurement of different iris flowers, including sepal length, sepal width, petal width, and species. We are using the head function to display the first 5 rows of the dataset. This helps us to verify that the dataset has been loaded correctly, to see the column names, understand the structure of the data, get a quick preview before visualization. Inspecting the data before plotting is a very important habit in data analysis. Now we'll create a scatter plot using the iris dataset to explore how species differ based on their sepal dimensions. So let's break this down step by step. We are using the Seaborn scatterplot function again. Here is what each of the parameter does. We are using the iris data set we just loaded using data equals to iris. The x equals to sepal length displays the horizontal axis representing the sepal length of the flower. Y equals to sepal width displays the vertical axis representing the sepal width. So each point in the plot represents one flower. The position of point shows how long the sepal is and how wide the sepal is. The hue equals to species is where the visualization becomes more powerful. The hue parameter colors the point based on the species column. The iris dataset contains 3 species. And Seaborn automatically assigns a different color to each species, creates a legend, helps us visually separate the groups. Now, instead of seeing just a cloud of points, we can observe how different species cluster in the feature space. The plt.title adds a descriptive title to the plot. The title clearly tells us we are comparing sepal length and width across different species. Clear labeling is essential when presenting data, especially in academic or professional settings. The plt.show finally renders the visualization. And that brings us to the end of the Seaborn course. Today you saw how easy it is to create powerful statistical graphics using Seaborn, from scatter plots and bar plots to histogram and box plots, and even multivariable visualization with just a few extra parameters. You don't need complicated code to create meaning visualizations, and with clear syntax and built-in statistical intelligence, Seaborn allows us to focus more on understanding the data rather than struggling with plotting mechanics. So here's what I want you to do next. Open your notebook, load the dataset, experiment with different plots, try changing the style or even the dataset itself. The more you practice, the more intuitive data visualization will become. If you found this video helpful, make sure to like the video, subscribe to the channel, and continue learning step by step. We are building strong foundations in data analysis, one concept at a time. Keep practicing, keep exploring, and I will see you in the next lesson.